audible to you? Hello, hello. If any problem is there, then type in message. Hello, 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 hello. Shall we start? Hello, shall we start? Hello, are you getting my voice? Are you getting my voice? Okay, so we'll start this one. So now today we are going to discuss bivariate probability distribution. In the previous classes, we discussed probability distribution, okay, for a single random variable. But now here we are going to discuss probability distribution for two random variables. Okay, why is here two variable? So since we are going to discuss probability distribution, so these are the two random variables. So we are talking about the two random variables. So recall that what do you mean by probability distribution? First, recall what do you mean by single variate probability distribution, or simply the probability distribution. So assume that let x be a random variable, okay, with its a probability function, with its a probability, that is p of x. Okay. So a random variable x with its probability function p of x, that is called probability distribution. Suppose that x takes the value x1, x2, x3, and so on xn, with its corresponding probability p of x1, p of x2, p of x3, and so on p of xn. So this table, this distribution, it's a distribution of a variable, random variable, okay, with its probability p of x1, p of x2, and so on p of xn. So such a distribution is known as a probability distribution that we learn in the previous classes. Okay. So with the help of this knowledge, we are going to turn to this bivariate probability distribution. So since here we are using x as only one single random variable, that we define x as a random variable to which represent outcome of a random experiment. Okay. So we are representing outcome of a random experiment. We are representing outcome of a random experiment. Any problem is there? Okay. So we are representing outcome of a random experiment with the help of one single variable. Yes. That's why simply it's called probability distribution, or single variate or single variable probability distribution. Just a minute. Okay. So instead of taking one variable, if we define two variables, if it consider two variables, for example x and y, x p of x comma p of y. Okay. So here two variables x comma y corresponding to the probability p of x comma y, that is known as bivariate distribution. If you, as in this way, if you write all the values of x, all the values of y, and if you define the probability function p of x y, okay, such p of x y, the two variables with its probability is known as a bivariate probability distribution. See this one example, by using one example. Consider this one. Suppose that consider one random experiment, okay, and consider that x takes a values. X is a random variable which takes values x1, x2, x3, and so on xn. Okay, and y is another random variable. Y is another random variable which takes values y1, y2, y3, and so on yn. Okay. Then the bivariate distribution for these random variables, that is written as p of capital X equal to x1, y equal to y1, like this way. That you have to obtain the probability for these points, x1 y1, okay, x1 y2, x1 y3, and so on. So we can write the probability like p of x1 y1, p of x equal to x1, y equal to y2, p of x equal to x1, y equal to y3, and so on. Y equal to y3 and so on. Similarly, take a combination of x2 and y1, y2, y3, and so on. So shortly, we can write the table in this form. Okay. Here you have to write the values of x and y. Y takes value here y1, y2, y3, and so on. Ym, and x takes value x1, x2, x3, and so on. Xn. वीडियो क्वालिटी खराब है. Okay, if you're not getting the video quality, then log out and log in. Rejoin the class. Maybe you will get the good video quality. Okay. So the 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 first probability p of x1 y1, that is written here like this: p of x1 y1. Okay. The second probability p of x1 y2. Simply we can write like this also: p of x1 y2, p12, and so on, p13, and so on, p1m. The first member denote the value of x. The first index denote the value of x. Okay, and the second denote the value of y. Second denote the value of y. Similarly, this can be written as p21, x is 2, the second value, and y is 1. p22, p23, and so on, p2m. Similarly, the last pn1, pn2, pn3, and so on, pnm. So all these denote the probabilities. All these denote the probabilities of the random variables. So we can denote this one by p11. Now these are the probabilities here. These are the values of a random variable. So such a table is known as a bivariate probability distribution. In case of a single random variable, as previously we discussed in the last classes, that the single random variable is denoted by the probability distribution for single random variable is denoted by p of x, that is here x1, x2, and so on, xn. So p of x1, p of x2, and so on, p of xn. Okay. So if x is a single random variable defined on a some random experiment, then the probability distribution is given by this one. It's a probability distribution for single random variable. If there are two random variables, then the probability distribution is given by this table. That is given by this table. Because there are two random variables, so you have to consider all its possibilities. What are the probabilities are there? Where x takes the value x1, x2, x3, and so on, xn. Y takes the value y1, y2, y3, and so on, yn. So you have to think about the combination. Like x takes value x1, y takes value y1. So probability is written here at the intersection of these two. For example, x takes value x1 and y takes value y2. So it is written here as p of 1, 2. For example, x takes value x1 and y takes value y3. So it's written as 1, 3. Okay, 1, 3 or 1, 3. Where x takes x1 and y takes ym. So it takes 1, m or 1m. P of 1, m. Where x takes value x1 and y takes value ym. Similarly, this one p of x takes x2 value and y takes y1. x2, y1, and so on. So these are your probabilities, and these are the values of a random variable. So such a table is known as a bivariate probability distribution. Such a table is known as bivariate probability distribution. Now we'll consider one example that you can easily understand how to prepare this bivariate probability distribution. Okay. So we'll discuss one example here. Just a minute. Okay, and this probability is known as joint probability. This is your simple probability. It's your simple probability because where x takes only value x1, x2, x3, and so on. Since we have the two values here, because it's a bivariate, so x takes x1 value and y take something y1 value, xi, y take yj value. So such a probability is known as joint probability because we have the two variables. Because we have the two variables. Now take one example. Any difficulty is there? Then let me know in the chat. Any difficulty is there? Okay, the bottom is not visible. Okay, now it will be visible, I think. Okay. Now we'll consider one example. Just write down this one example. Suppose that we have one bag, okay, which contains something three red balls. There is one bag here which contains three red balls and four white balls and five blue balls. Okay. So there are 12 balls. There are 12 balls. Okay. And now randomly we are selecting three balls at a time. Randomly we are selecting three balls. Okay. So our aim is to select three balls. Randomly we have to select the three balls. So just calculate what is the probability that all the three balls are there is no, you can say, no blue ball and no red ball. Okay. Just see, since we are collecting three balls here, and suppose that x is a random variable which denotes red ball, and suppose y is a random variable which denotes white ball or number of white balls. X is a random variable which denotes number of red balls, and y denote the number of white balls. Okay. So our aim is to calculate what is the probability that the three balls they are selected, okay, they all are blue, or all the three are red, or all the three are white, okay, or one is blue, one is red, whatever the various combinations. Whatever the various combinations. Okay. See here, we are selecting this one. See, first of all, list out what are the various combinations. Red ball, blue ball, and white ball. Okay. So since we are selecting three here, okay, and so there are three red balls, so the possibility is that we can select all three red balls. All three red balls. So blue ball is 0, white ball is 0. That is one possibility. Okay. Or there may be a possibility that all are blue balls, white are 0, and red are 0. Okay. Or all are three are white balls, the remaining are 0. That is one possibility. Okay. Or you can say that we can select all are one red, one blue, and one white also. Okay. Or you can select two reds, one blue, zero white, or two reds, zero blue, one white. These are the various combinations. These are various combinations. So, but since our interest is to for selecting only red and white, okay, we have to drop this blue combination. We have to drop this blue combination. Since our interest is to check how many balls are red and how many balls are white. Okay. So we assume that let X denote number of red balls and Y denote number of white balls. Okay. So see here how we can write this combination. Okay. Suppose that we selected the three red balls. Okay. So you have to calculate what is the probability of getting three red balls. So if there are three red balls, it means that there is zero white ball. It means that there is zero white ball. So we can write P of x equal to 3 comma y equal to 0. P of x equal to 3 comma y equal to 0. Uh, is there any difficulty? Is it not clear? Just a minute. Now it's clear? Now it's clear? Since our interest is to take only red and white, okay, so there is a zero blue ball. Okay, so there is no need to write zero blue ball. There is no need to write zero blue ball because what is the probability of this one? So see here, since we are selecting three balls at a time. So see what are the number of ways to select three balls. Okay, so it's a 12C3. Simply it's a 12C3. Okay. Out of 12, we are selecting three balls. So if you simplify this one, what will you get here? It's a 12 factorial divided by 3 factorial into 12 minus 3. 9 factorial. Okay. And if you simplify, you will get 220. Sorry, 3C3. And we are selecting 0 white ball. So it's a 4C0. As you have said that, you can mention the blue ball also here or you cannot mention here. If you want to mention here, then you write 5C0 because we are selecting 0 blue balls. If you have written it's okay, otherwise you can leave it this part for blue balls as you are told. So divided by total number of cases, it's a 220. So just you have to simplify that it's a 3 by 220. So the probability of getting three red balls where the zero white ball, that is your 3 by 220. Okay. So in this way you have to calculate all the probabilities. In this way you have to calculate all the probabilities. As a combination I have written the first one only. Okay. What is the probability that the three white balls are chosen where the zero red ball and zero blue balls? Okay. So we can write here the probability of this is the probability of getting of three red balls. Three you can say white ball. Probability of three white ball. Okay. That is denoted by P of x equal to 0 because there is zero red and the white ball 3. So how we can find this one? Okay. So there are zero since we are selecting zero red ball among the three. So 3C0 into 4 out of 4 we are selecting 3 white balls. So 4C3 and 0 blue balls. So 5C0 divided by 220. Divided by 220. Just simplify this one. 3C0 is 1, 5C0 is 1 and 4C3. So how much it is 4C3? It's a 4. So it's a 4 by 220. So there are 4 ways to select a 3